Alright guys, today we are looking at a couple more of our shortcut methods. So in our last lesson we talked about side congruence. Today we're going to talk about side, angle side, and hypotenuse leg. So first off, side, angle side congruence postulate says that if two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the two triangles are congruent. The key there is that the angle is included, meaning it is between those two sides. So if you look at the triangles in the picture, you see that arc being between the two tick marks. So we couldn't have an arc like an angle S and angle V, or an angle T and angle W, because it wouldn't be between those two marked sides. So RS we see matches up with UV. Angle R matches up with angle U, and RT matches up with side UW. Then we know that triangle RST is congruent to triangle UVW. Make sure that order still matches. We're going in the same direction, same corresponding pieces. So let's check out this first example of a proof that we're doing. So we have Jn is congruent to Ln and Kn is congruent to Mn. And I'm going to go ahead and write that. And then I notice it's also not marked in the picture, so I'm going to mark it in the picture. So Jn is congruent to Ln and Kn is congruent to Mn. My reason is going to be given. So Jn and Ln are going to get a single tick mark, and then Kn and Mn are going to get a double tick mark. Then I also want to put the proof statement down in the last spot. So triangle JKN is congruent to triangle LMN. So then we only have reasons 2 and 3 to come up with. Okay, so we're looking back at the picture and it says angle 1 is congruent to angle 2. We have to decide why that's true. Well, angle 1 is congruent to angle 2. Notice these are vertical angles touching at just the vertex. So that would be our vertical angles congruence theorem. Okay, and then our last reason, if we know they're congruent, I'm going to put the arcs there. So angle 1 is congruent to angle 2. I notice that I have the single tick mark on the side, and then I have the arc, and then I have the double tick mark. So if I travel around the triangle, I get side, angle, side as my reason. All right, our next theorem is the hypotenuse leg congruence theorem. And think about where you've heard that word hypotenuse before. Hopefully, the image of a right triangle is coming to you, and the hypotenuse is always the side that's across from the right angle. So there's our hypotenuse. So even though it only says hypotenuse leg, that's two things, the key there is that it has to be a right triangle. So we see the right angle, and then we see the hypotenuse and one other side marked. So you need those 3 pieces for this hypotenuse leg to work. So that the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. So let's try this one out. Got a lot of information for our given. I'm going to throw it all into that first statement. So AC is congruent to EC. AB is perpendicular to BD. ED is perpendicular to BD. And C is the midpoint of BD. Our reason for all of those is given. So now I see definition of perpendicular. So I'm going to look at the two statements that have perpendicular in them. So AB is perpendicular to BD and ED is perpendicular to BD. Well, when you hear definition, you want to think, what does that word perpendicular mean? So perpendicular means meets at a right angle, right? So we can say then that if AB is perpendicular to BD, then we know that angle B is a right angle. We also know, though, if ED is perpendicular to BD, then we know that angle D is a right angle. So that's our definition of perpendicular. So then, if we have right angles there, the next statement says triangle ABC and triangle EDC are right triangles. Well, we know that if we have a right angle and a triangle, then they have to be right triangles. So by definition of right triangles. The definition of a right triangle. Okay, so then the next one says BC is congruent to DC. There's nothing in the picture that I would notice there, but I do see from my given statement that I haven't used that C is the midpoint of BD. So if C is the midpoint of BD, I know that that means, by definition, that those two segments are congruent to each other. So our reason here is our definition of midpoint. Okay, and then I didn't do this at the beginning, but our last statement here is just our proved statement. So triangle A, B, C is congruent to triangle E, D, C. And why? Well, I notice I have that right angle, so that should be a red flag thinking of hypotenuse. The hypotenuse is marked across from the right angle, and I have another leg marked. So that would be our hypotenuse leg theorem. All right, guys, that's all I have for you for today. So, as always, keep practicing. Come in and see me if you have any questions. Have a great day.